Okay, so today we're going to talk about rocks. This is rock basics, so we're going to actually come back to this in more detail with the different rock groups. So first we just determine what a rock is. A rock is a naturally occurring mass of solid material. It can be made up of minerals, fossils, and organic material. This is a little bit different than a mineral because minerals have to be a pure compound or a pure element. A rock is a mixture of different minerals, fossils, and there's organic material. Remember, minerals are always inorganic, so rocks can actually have organic stuff in them. And due to processing within or outside the Earth's surface, they form. So remember we talked about our common elements in the Earth's crust. And then we talked about our common minerals in the Earth's crust. There's what? What is the most common mineral in the Earth's crust? Silicon is the most common element, that's right, and oxygen. So what makes our most common mineral group? Silicates. So silicates are the most common mineral group in the Earth's crust, which is actually predominantly what makes up most of our igneous rocks, or silicates. So basic information, igneous rocks are formed due to the hardening or cooling of molten material. And the molten rock is caused by the heat of the Earth's core. We identify igneous rocks based upon their visible mineral crystals. So here you'll see like this one here has a lot of mineral crystals. And that one's considered a granite or an intrusive igneous rock. And then this one has small mineral crystals and is actually an extrusive igneous rock. It formed very quickly. So they can form inside or outside the Earth's surface. And the location of formation affects the crystal size. The faster the rock cools, the slower the crystal. I didn't say that right. The slower cools, the bigger the crystal. The faster cools, the smaller the crystal. This is the most common rock type on Earth. Sedimentary rocks are the second group. They make up 75% of all rocks exposed on the Earth's surface. They're the second most common rock type. However, that is not necessarily true in New Hampshire. And we'll talk about that. So sedimentary rocks are made up of sediment. They're loose materials such as rock fragments, mineral grains, and organic material that's been moved by wind, water, gravity, or ice. And they form when sediments are pressed and cemented together, or when the minerals form from solution. You often identify sedimentary rocks upon their sediment layers, but they don't necessarily have to contain layers. So for instance, this one here does not have layers. It's everything is just kind of bunched together and cemented together. Whereas this one has layering, because it was probably formed in some sort of water environment, like a riverbed, a delta, an ocean, or a lake, where you get those nice fine-grained layers. The third type of rocks are metamorphic rocks. Rocks are become metamorphic when you have changes in temperature and pressure, or the presence of a hot, watery fluid that's usually at a converging plate boundary. So you have a hot water source that has lots of different minerals in it, dissolved minerals, that get in between the cracks in the rock and can actually change the rock composition. You can get metamorphic rocks from sedimentary rocks, igneous, or other metamorphic rocks. For instance, granite, when put under heat and pressure, goes from granite to gneiss to schist. So the whole world is full of schist. No one's laughing at my joke. Come on.
I get it.
So Typically, you can identify metamorphic rocks due to the flattening of mineral grains or crystals due to the pressure. This is the least common type of rock, although we do have a lot of metamorphic rock here in New Hampshire. Now, to go back for a second, I'd said all of the sedimentary rocks are 75% of the Earth's surface, except in New Hampshire. Why might New Hampshire not have as much sedimentary rock? And it's actually not just New Hampshire. It's kind of the whole northern part of the United States, pretty much south to about New York. Not a whole lot of sedimentary rock there. Allie? What?
Like winter snow.
Oh, snow has something to do with it. Really long snow event, 10,000 years ago. Brian? Ice Age. So the glaciers actually moved a lot of the sedimentary rock as it pushed, the glaciers pushed south. They pushed a lot of the sedimentary rock that was here further south. So actually Cape Cod and areas like that are actually formed because of the glaciers. They're actually what we call glacial moraines, which we'll talk about later. So now the rock cycle, we're going to do more of this with the next rotation, but the rock cycle is that rocks are continually changing and they're neither created nor destroyed. They just change form. Okay,